Hello everyone, today we are going to go through multiplication and division of decimal fractions. Decimal fractions without using a calculator, this is grade 9 work as we can see. And at this level we are not allowed to use a calculator so that our logical reasoning acumen will grow. So, how do we go about this type of sum? Let's take an example to illustrate this. It says, evaluate the following without using a calculator. 0,04 multiplying 0,015. So the approach we use for this is to remove all the decimal places, multiply whole numbers, and then when we are done, we also take back the number of decimal places that we've taken out. And that applies to every time we are multiplying decimal fractions. So what we do here is we take out the decimal places here. If we move towards the right, we take out 2 decimal places and this number becomes 4. We do the same thing for the other side. We took out 3 decimal places to make it 15. So here we took out 2 plus 3 decimal places. So in all, we took out 5 decimal places, and that is what we are going to return when we are done. So now we can easily multiply whole numbers. We have 15 times 4, which will give us 4 times 5 is 20. Write 0, take here 2, carry here 2 over. 4 times 1 is 4 plus 2, 60. So our answer will be 60. Our answer is 60. The next thing we do is we need to place back the number of decimal places we took out. So 60 is the same thing as 60.0. Since when we were taking out the decimal places, we were moving towards the right. So this time we will have to take it back to the left. The number of steps 1, 2, 3, 4, 5. And our decimal place will be here, which is the same number of steps we took out. So we fill in the empty spaces with 0, and this gives us our answer, which is 0,00060. And that is the solution to this problem without using a calculator. So when you are multiplying decimal fractions, take out the decimals. Record the number of decimals you take. Even if you have like 5 times, it's still the same approach. And when you are done, return back the number of decimal places you took out. So that is the approach for multiplying. Let's look at division. It's slightly different and also uses a different approach. So for division, we will take a sum, which is evaluate the following again. So we have 0,140 divided by 0,07. If we have this and we are asked to divide, the approach here, remember previously for multiplication, we take out and return, but the approach here is we also take out the number of decimal places that we have, but we don't return anything. What we do to balance it is, for the numerator, the number of decimal places we take out must be equal to the number of decimal places we take out in the denominator. When we even it out and divide, whatever we have is our answer. There's no need to take back anything. So here, always work with one that has the highest number of decimals. So here we've moved 3 steps. It means for the denominator, for it to even out, to balance, we need to also take out 3 decimal places. So we also take out 3 decimal places. And then when we take out those 3, the empty space will fill up with 0. The numerator in this case becomes 140, and then the denominator becomes 70. You see how easy it is. When you take out even number of decimal places for the numerator and the denominator, you have whole numbers which are more simplified, and then you can easily answer your question. And here for division, we don't take back anything, we only take out evenly, and this is the answer to this sum. Going forward, these are the basics we look at when we have variables and when we have variables and how to deal with them as well. But the method and the approach remains the same, irrespective of the fact whether we have variables or not. The only thing is that the variables will apply exponential rules to solve the problems, but these are the basics. Let's take one question with variables. If we are multiplying, for instance, if we have 0.32a to the power of 3 times 0.8 a to the power of 4, for instance, and we're asked to evaluate this without using a calculator, the problem here may just be the variables, but it doesn't give us any problem if we know the averages. So what we do is we focus on dealing with number and number items, and then variable and variable will multiply separately, and we'll still get our answer. For the number here, the same approach. We move out all the decimals. If we move 2 steps, this becomes 32. On the other side also, if we move 1 step, this becomes 8. Now, if we check, we move 2 decimal places here, and we've moved 1 here. So in all, we are supposed to return 3 decimal places because this is a multiplication problem. Now, if we have simplified this, we only have 32 divided by 8. 32 divided by 8 can easily be solved. We have 8 times 3 is 16, we take 1 over 8 times 3 is 24 plus 1 is 256. So we have 256 as our answer. Remember, 256 is the same thing as 256, 0. Now we go back to complete the sum by checking the number of decimal places that we took out. Looking at this, we took out 3 decimal places, so we also return the 3 decimal places that we took out. So 1, 2, 3. On the opposite, our decimal place falls in here, and our answer becomes 0.256. That is for the number. Let's look at the variable involved in this. The variable says a cubed times a to the power of 4. You can do them together, you can do them in bits. Laws of exponents says that if we have any exponent multiplying another exponent, but they have the same base, but different or even similar exponents. For multiplication, it says we should use a common base. So here we use a common base, which is a, but add their exponents. Add their exponents. Use a common base, so long as they have a common base and you are multiplying, just add their exponents. So this will be a to the power of 3 plus 4, which is a to the power of 7. So our answer to this sum is 0.256, a to the power of 7. And that is how we resolve decimal fractions, multiplication of decimal fractions involving variables. Even if you have 4, 5, 6 variables, the same approach is what we use. Number to number, variable to variable, and we will get our desired answer. The last step we are going to check here will be division of decimal fractions when they have variables involved. Let's take that example also. So let's take this one. It says 0.56 x squared y cubed divided by 0.14 x cubed y to the power of 2. If we have this example, it doesn't matter if we have multiple variables or not. The laws of exponents is what we use to resolve the variables. And we use our rule for division of decimal fractions to resolve the numbers. So the same approach will deal with number to number, variable to variable. Remember, the variables we can only deal with are the ones that have similar bases. So we can only deal with x and x, y and y. If we can't deal with x and y because they do not have the same base. So let's go. For the numbers, same approach. For division, take out even number of decimals. So if we take out 2 from the numerator, it becomes 56. If we take out 2 from the denominator, it becomes 14. Now with this, 56 divided by 14 gives us a 4. 56 divided by 14 gives us a 4. Now for the variables, we apply the laws of exponents, which say that if I have two exponents of the same base being divided by each other, subtract their exponents. Remember, we are subtracting the numerator, is the numerator minus the denominator. It's not the larger number minus the smaller number. So here, the first one is going to be x to the power of 2 minus 3, because it's x to the power of 2 divided by 3. So this will give us x to the power of negative 1. And for y, we have y to the power of 3 minus the denominator, numerator minus the denominator, and we have y to the power of 1. So our answer will be 4x to the power of negative 1 and y to the power of 1. Which, if we want to present as a positive exponent, becomes 4y all over x. And this is how we resolve decimal fractions involving multiplication and division. If you have specific questions that you want us to answer, please do not hesitate to pop in the comment section, and please continue to share and continue to help your fellows who are still struggling. We are here to help and to solve any problem that you have encountered. I'll see you in the next video.